Hi, my name is Ryan Dahl, creator of Node.js and Deno. Today, we're releasing our biggest update yet, Deno 2. Let's go check it out. JavaScript is the world's default programming language. It's deeply rooted in human infrastructure because it's part of the web, like HTTP or CSS. And it's not going away anytime soon. It's going to be here 5, 10 years from now, if not 20 years from now. And because of that, we are building on JavaScript. We want to make it great. Deno is a runtime for JavaScript development. It natively supports TypeScript as well. And it tries to narrow the gap between browser JavaScript and server-side JavaScript. It uses web standards, ES modules, Fetch API, all sorts of stuff. It is an all-in-one toolchain for JavaScript development that's really batteries included. It has all of the utilities you need. It's secure by default and backwards compatible with Node, and we'll see that in action. Deno is the simplest way to get started programming TypeScript. You can really just open a single file. You don't need to create a package JSON or have a Node modules folder. A single file is all you need to get started. Let's see that in action. I'm going to create a ls program, listing the files in a directory. And let's see how that looks in Deno. Let me just create a main TS file and let's open up VS Code. So to list the files in a directory, there's an API called readdir, deno.readdir. This is one of the built-in Deno APIs. And it takes a path as an argument. You can see kind of the built-in documentation working here, and the built-in language server kind of giving me a red squiggly because I don't have any arguments. So I'll give just the current directory dot as the argument to start with. And this thing this command, this function returns an async iterable that lists the elements in the files in the current directory. Let's try to loop over these using an async await. Const entry of deno.readdir, and for now, let's just console log that entry out. So if we run deno main ts, you'll see the secure by default permission prompt in action here. So we're trying to access the file system. Deno doesn't allow you to do that unless you explicitly give it permission. You need to give it the allow read flag or say yes at this prompt. If you do, it will work. But often you don't want to click through a bunch of permission prompts. You probably want to give the allow read flag that lets you do this, or the shorthand version of that is -R to give the allow read permission. Let's expand this a little bit. Instead of using dot as the hard-coded directory that we're going to list, let's actually take an argument from the command line. So we'll use deno args 0 here. And we can, of course, do dot, or we could do, I don't know, a different directory that has a bunch of files in it, like this one. Let's abstract this a little bit further, turn this into a function. So tree, we'll call it tree, and let's say it takes an argument called dir, that's a string. And let's say this tree function just returns a bunch of strings in an array of each of the file names. So we'll move that loop up here. And you can see that we're getting some red squigglies here from the language server. This is saying that we're doing a for await loop outside of an async function. So let's just add an async here. By the way, you can see these same errors if you do deno check. So just to back up a bit, we'll do deno check main ts, where you can see these same errors. But it's often more convenient to see this in the LSP. It is complaining because I'm not returning a promise. Of course, it's an async function, so let's add promise there. And it's still complaining because I'm not actually returning anything. Duh. So const out equals empty array, and we'll just push out And entry is actually an object. Let's actually output the name of just the name of the file there, and we'll return out at the end. And then of course we need to call this thing. So let's say await tree, and we'll do Deno args 0 here. And let's just console log out those files. And I'm realizing that I'm actually not using the argument here. I should change this to a dir. And yeah, it's red squiggly because I'm missing a parentheses. Okay, so how does that look? Yeah, all right, so now we've kind of abstracted this out into a function. As I said, Deno is an all-in-one runtime, and it combines a lot of disparate tooling that you need in the Node ecosystem into a single binary. Deno is literally a single file. So for example, you might use prettier in Node to format your code. In Deno, it's just Deno format. Or for type checking, you might use TSC. In Deno, it's just Deno check. Or maybe you use ESLint in Node. You can do the same thing with Deno lint, and many more. Let's take a look at one of these subcommands in more detail, Deno compile. So this actually takes your JavaScript and bundles it together with the runtime and creates a binary output, just called the Deno compile subcommand. And as you can see, it has created this demo file here, which is a ARM64 Macintosh executable file. And we can just call that like we would any other program. Of course, we need to give a proper file name here, and it works as normal. So you can distribute this without Deno, and it will continue to work indefinitely. It doesn't depend on any other files. One cool feature of Deno compile is that it can actually cross-compile. So if you do -- target, it will give you a list of possible platform targets that you can give to it. Let's try to cross-compile this program for Windows. So we'll do an x64 Windows binary, if I can spell target correctly. And as you can see, we now have a demo.exe file that is appropriate for running on Windows. I don't have a Windows computer here, but suffice it to say, this demo.exe is appropriate for running on Windows. But you could do all of that with Deno 1. Let's talk about Deno 2. Deno 2 is a revamp in multiple areas: ecosystem compatibility, package management, and enterprise features. Let's start with ecosystem compatibility. One of the things I've heard the most from users of Deno is that they love how simple Deno is. They don't have to have any configuration. They can just get started with TypeScript. But inevitably, they come across some existing Node project that they need to interact with, whether it's an NPM library or some existing project. Deno 2 is fully backwards compatible with Node when using ESM. And Deno 2 understands your package JSON, Node modules, and NPM workspaces. NPM packages are supported, even complex ones like gRPC, or ones that use native extensions, the so-called NAPI. This allows you now in Deno 2 to incrementally adopt Deno without doing an overnight stop-the-world full migration. To see a complex Node application running in Deno, let me show you create next app. So create next app, of course, creates kind of a boilerplate Next.js application. And normally you would do npx create next app. In Deno here, I'm actually going to Deno-a npm create next app. And yeah, we're going to run kind of the creation script. And let's choose all the default options here. And wait a second while npm installs it. takes a while because NPM is slow. We'll see how to alleviate that in a second. Possibly the internet is slow. Possibly I don't have internet. Okay, no, I do have internet. Here it is actually forking out to Node and using NPM. But when we're done, we finally have this my app folder with a Node modules folder in it, of course, and a package JSON, a typical create next app. In Deno now, Deno understands all of these things. So you can run Deno task and you'll see a list of available commands here like Deno dev and build and start and lint. Let's run the dev server now with Deno. So Deno task dev will actually start the Next.js dev server here at port 3000. And yeah, you can see it running. Just to kind of clarify that this is working correctly, let's just edit this page TSX file and we'll just say get started by editing and write Deno instead here. And yeah, hot module reloading works. All of this is being executed by the Deno runtime. It's not just Next, Remix, Astro, and many other frameworks are supported by Deno. In addition to full backwards compatibility with Node applications, all Deno programs can now import Node libraries in the form of NPM packages without requiring a package JSON or Node modules folder, and secure by default execution is maintained. Let's take a look at this in action with our LS example here, and let's just try to make some color output using the npm chalk library. To do that in Deno, you can just do import chalk from npm:/chalk. Note auto formatting is happening in the background, and we can just use chalk as normal. So chalk, say BG blue for a blue background, and files is actually an array. So let's just kind of join that with new line character. So Deno main TS, running this again will hit this permission prompt. So what's happening is that chalk is trying to access various environment variables. Force color here, let's allow that by saying yes. TF build, let's allow that. Term, CI, team city version, color term. If we say yes to all of those, we do finally get the proper output here with blue background color. We can avoid those permission prompts by adding in allow env flag, and then we don't get those, or just a -E for short, Deno-RER. But actually, there's a better way to do this in Deno. Let me show you how you can get color outputs, just as an example of kind of how Deno uses web standard APIs, how you can get color output in a way that also works in web browsers. So console log %C actually allows you to supply some CSS. So we'll do files join \n. And we can just say background color. Let's change it to red for. And this should give us our red background LS for whatever reason you might want that. This doesn't actually read any environment variables, so we can remove the allow env flag from the execution. Just to recap, in Deno 2, you can run existing Node applications. Deno now understands your package JSON and Node modules folders out of the box. And if you're not using package JSON, Deno allows you to use the full breadth of NPM libraries in your Deno code without any configuration and allowing them to be secure by default. And that's ecosystem compatibility. Now let's talk about package management. With Deno's support of package JSON and Node modules, we've added 3 new subcommands to help you manage these. They're really similar to NPM. You should basically immediately know what they do. Deno install, Deno add, and Deno remove. Deno install inspects your package JSON and installs dependencies, but really, really fast. When you have a package JSON, Deno will install your dependencies in the node modules folder, creating one in your project tree. If you don't have a package JSON, it will look at your Deno JSON file, find any dependencies in an import map, and cache those globally. Deno add and Deno remove are really simple subcommands that add and remove dependencies from a package JSON or Deno JSON file. Let's take a deeper look at Deno install. We're back in our Create Next app, where we have a node modules folder that Create Next app created. Actually, npm install created this. Create Next app ran npm install. This is a folder that has roughly 319 megabytes of dependencies. Let's see what Deno install does by just removing this directory and then running Deno install. It happens really fast. Now we have a new node modules folder with the same size as before. And of course, you can run Next.js by running Deno task dev. That's what Deno install does. But if this was all there was to package management in Deno, this would be pretty disappointing, which is why it's not. Let's talk about JSR, the successor to NPM. JSR is a new package registry where you can publish JavaScript code and share it with people. And it's not just JavaScript. TypeScript is also supported. JSR is meant for the future. It is a registry that is not just for Node, but for all JavaScript runtimes. And we need a registry that can support all of those different runtimes. JSR only supports ECMAScript modules, not CommonJS, so kind of forces you into the future in a certain way, and is really designed to work with NPM and not against it. So meaning that packages in JSR can actually have NPM dependencies. So in a sense, it's a superset of NPM. JSR, of course, provides really great developer experience for consumers and publishers of packages, and we'll see that in a second. Deno standard library has been developed over the past 4 years. It's a great set of utility functions in all sorts of areas. And we have now stabilized the Deno standard library to 1.0 and published it to JSR. Also, this set of libraries is not just for Deno now. You can actually import a lot of the standard library modules in Node and other runtimes. So instead of needing to know all sorts of different NPM packages, you can actually just use this standard library. And my hope is that this can serve as a base and help level up JavaScript. So for example, instead of using jest, you might use testing, or instead of using chai, you could use expect. Or for command line flag parsing, maybe instead of using minimist, you can just use CLI. Or instead of Lodash, use collections. And many other packages are available. Let's make use of one of these standard libraries, the file system library, and we'll try to use that to improve our LS demo. So let's just go to the JSR website and search for stdfs. And this has various file system functionalities, helpers for file system. And let's search for walk here, which gives you the functionality to kind of recursively walk through a directory tree. It's really similar to the Deno readdir, except it's recursive. So it also takes a string argument and returns an async iterable. Let's make use of this by just copying this import here and pasting it into our demo. We can make use of it basically immediately by replacing the Deno readdir with walk. And that's all that we need to do here. We can just run this code now, and you might notice that there's quite a few more files now. Let's actually change, so it's entry.name is just the file name, but if we do entry.path, we'll actually get absolute paths of all of these things. And you can see that it's kind of recursively jumping into like the JSR directory in this case. Let's actually make those absolute paths into relative paths by using one of the Node built-in libraries, Node Path, just to give you a sense of what it's like to pull in Node built-in libraries. So you can import relative from node:path, a library that I assume many people are familiar with. And all we need to do here is replace this entry path here with relative dir, entry path to actually make these relative paths. So that's all there is to pulling in JSR dependencies. Again, we don't need to create any extra files. There's no node modules folder. There's no installation at all. It kind of happens automatically. Let's say we want to publish this and share this tree function with people. Let's see what it's like to actually publish to JSR. So all I need to do here is go into my JSR window, my browser, and click Publish. And I'll publish this under the RI scope. And the package name, let's call it Demo. And when you click Publish here, it's going to give you a little JSON snippet that you can drop into jsr.json or Deno.json. And let's just create, I'll do a Deno.json. So I'll create a Deno.json file. And I'm just going to update the version here to version 3 because I've tried this before. And yeah, the exports actually, I don't have a mod TS, but a main TS file. So let me modify that. And then in my main TS file, I need to export this function. And I don't actually want these two lines here at the bottom to execute on every time you import it. So I'm actually going to wrap those in if import meta main and yeah, we should be ready to publish. So all we need to do is run Deno publish. And I'm getting two errors here. The first one is on line 1 with this JSR import. I don't have a version specifier. So it's fine to import packages from JSR and not have a version constraint. But if you're going to use those packages and publish a library to JSR, you actually need to be a little bit more specific about what version you're depending on so that we can resolve those packages concretely. And we'll depend on version 1, Semver version 1 of that. The other thing it's complaining about here is a missing license field in my Deno.json file. So let me add license, and we'll just call it MIT. And let's run Deno publish again. I need to authorize this publishing. Again, I'm logged into the website, and we have some security constraints on JSR. Wait a second, and yeah, this is now published. So you can see the doc generation happening here, and you can see the tree function has been published to JSR. There's no actual JS doc or documentation for this yet. And yeah, maybe I'll just show you what it's like to add some docs here. So let me add some JS docs. So we'll just say recursively list out files in a directory. And all we need to do then is bump the version and run publish again, approve it, wait a second. And there we go. Now we can see the doc string represented in the auto-generated documentation. To recap package management improvements, we've added 3 new subcommands, Deno install, Deno add, and Deno remove to help you manage package JSON or Deno.json files, the dependencies in them. We've introduced JSR, a modern registry for publishing JavaScript and TypeScript code that supports all runtimes. And we've stabilized the Deno standard library to Semver 1.0 and published it to JSR and made it available to all of these different runtimes out there. That's package management. We've been talking to a lot of users at larger companies about their usage of Deno, and the feedback that we've received is that it's great, but there are a couple of missing points. Private registries, monorepo support, and stability guarantees or long-term support. So let's talk about each of those. First of all, private registries are now supported in Deno 2, essentially in the same way that they're supported in Node. You can add a .npm-rc file, use the same syntax that you do in Node, and you can access your company's internal private registry server. That easy as that. You can pull in those private NPM packages. Deno Workspaces is similar to NPM Workspaces, in fact, interoperates with NPM Workspaces, but essentially is monorepo support. It allows you to have multiple packages in a single monorepo. And Deno Workspaces lets you mix and match package JSON modules and Deno JSON modules seamlessly and has the great developer experience that one knows and loves from Deno. We've seen that larger, more mature development teams can't upgrade at the same cadence that we are releasing Deno minor releases. We release every 6 weeks. So to help support those teams, we are introducing long-term support branch, LTS releases. This is going to start with Deno 2.1, which will be released in October. And we will be backporting critical bug fixes to this branch for 6 months. This LTS release, of course, will be MIT licensed, freely available like the rest of Deno, but is largely aimed at companies that need to kind of vet individual binaries or have processes for introducing new versions. We have additional enterprise support, commercial support available. You can learn more about that at deno.com/enterprise. I want to touch on Deno's performance. Deno's performance is great. For instance, Deno's HTTP server has almost twice the throughput as nodes. JavaScript runtimes are multifaceted and have lots of different functionality. And so it's hard to sum it up in a single number or a single graph. But here are a number of benchmarks that give you some broad idea of how Deno performs. Overall, Deno performs fantastic. And there's much more. We're just scratching the surface here. We haven't talked about Web GPU. We haven't talked about Deno's documentation generation. We haven't talked about our FFI or Fresh or Deno deploy. I do want to leave you with one more demo here on our Jupyter Notebook support. So I'm going to just open up Jupyter Notebooks. And I'm going to create a new notebook. All you need to do is switch the kernel from Python, the default, of course, to Deno, and you can now execute some Deno code. What I'm going to do is pull in observable plot and plot some stuff with JavaScript. So let's do that. So import star as plot from npm:/observable_hq/plot is, let's make sure that works. Yes. Observable plot is just a fantastic graphics library for analyzing data. I need a little bit of data to analyze, so let me pull in a data set called penguins. So import penguins from, and this is just a little library that I have called Jupyter-helper on JSR. Penguins is an async function that returns some data, so I'll just await penguins, and let's see if we can actually load some data here. Yeah, so here's a table. This data set is a bunch of measurements of penguins, just kind of a sample data set. We need one more object here, which is a document object, in order to interact with observable plot. So let me assign this penguins data set to P here, and let me print it out again just so I can see. And yeah, let's do a scatter plot with kind of two rows of this data here. So observable works like this. You do plot plot, and you give it some marks, which is an array, and you give it this document. Inside of marks, if you want to do a scatter plot, you do plot dot, and we'll just do p2 records to get our penguins data set in the right format. And then we just need to give it x and y coordinates here. Yeah, let's just say const x equals Coleman length. I think this is some measurement of a penguin's beak size, maybe. And I don't know, let's measure it against flipper length. Const y is flipper length. And yeah, there we go. We have a scatter plot. It's black and white, maybe not so interesting. Maybe we can add some color here and kind of color it based on species. And yeah, suddenly you can kind of see 3 different species of penguins kind of broken out by their flipper length and beak lengths. So yeah, just to take everything full circle here, let's pull in that tree function that we just published to JSR and plot a directory tree with that. So first of all, import tree from JSR:\ri/deno2-demo. And yeah, let's just make sure this works. So await tree users, ri, src, deno, runtime, my favorite directory. And yeah, we've got an array of data here. Let's assign this to a variable, files, let's say. And yeah, let's do some observabling. So plot marks is an array, and we'll just do plot tree, and we'll give files here, and again, document. And yeah, suddenly you have a visual representation of a file tree. You can maybe even clean it up a little bit more by turning off the axis and giving it a margin. But yeah, same thing. Observable is super cool. Check it out. And it interacts very nicely with Deno and Jupyter notebooks. Like I said before, there's so much more to Deno. We're just scratching the surface. Deno is ready for production now. I can't wait for you to explore it. And by the way, we're also introducing a new logo, so check that out. Thanks, everyone.